Now, if x follow by norm with parameter np, now I'm going to say this. Binomial distribution is a generalization of Bernoulli. Okay, binomial distribution also module a random variable with two possible outcomes. The only difference between Bernoulli and binomial is that the numbers of trials involved in binomial is more than one. Does that make sense? Okay, now, what is the PMF? When I say PMF, I mean the probability mass function. So the probability mass function is this, n combination s, p raised to power s, 1 minus p raised to power n minus s. S start from 0, 1, 2 until we get to n. Now I need you to take a look at the state space of binomial here. Okay, 0 to n, but that's of the Bernoulli 0 to 1. Okay, now take a look at this guy now. Okay, now when you take a look at what I have here, okay, the expected value of s equal to np, the variance of s equal to np into 1 minus p. At times you could write npq, okay, where q is 1 minus p, okay, because q is the probability of failure and p is the probability of success. Now, how do I derive this? Okay, so how do I derive this? Now, expected value of s, summation s start from 0 to n, okay, x p of x, okay, because binomial is also a member of a discrete probability distribution. So now I'm actually gonna write, you know, you can be, some of you may be confusing this with this, so you can decide to write a lowercase. That's no problem, okay? Now, s start from 0 to n, x, now the distribution, okay? And combination s, p raised to power s, 1 minus p raised to power n minus s. So take a look at that. Now, right here, s start from 0 to n, x. If you take a look at this guy, is n factorial, n minus x factorial, x factorial. That is the definition of this guy. So p raised to power x. Now, 1 minus p, I can simply write q. Okay, I told you q is we're setting as 1 minus p. Now, when you take a look at this guy now, I can rewrite this as s start from 0x, s factorial can be written as n into n minus 1 factorial. This n minus x factorial, s factorial, s into x minus 1 factorial. Then I got p raised to power s, q raised to power that. Okay, now this is definition of factorial. 5 factorial, 5 factorial is the same as 5 times 4 factorial. I think you know that, right? Okay, so here n factorial can be n into n minus 1 factorial. X factorial can be x into x minus 1 factorial. Now this x cancel that. Okay, now I can bring this n here. I'm actually going to have n. If I bring n, now right here, okay, right here, I can introduce p and p raised to power minus 1. This is going to cancel that, right? Okay, now what I can do now, I'm going to bring this p outside here. Okay, when I bring this very p outside here, then I can combine this and this. That's going to be p raised to power x minus 1. So here, I'm actually going to have n minus 1 factorial, n minus x factorial, s minus 1 factorial, p raised to power x minus 1, and this. Take a look at this now. Okay, now the moment I have that, okay, Okay, so the moment I have this guy now, okay, what I'm actually going to do, if you look at, P here is carrying x minus 1, and you can see x minus 1 factorial here. Q is carrying n minus s. Now, do you know that this n minus s, n minus s is the same as n minus 1 minus that? You know that? This is the same thing as this, mathematically speaking. So if I want to rewrite it, I'm actually going to write, okay, np summation n minus 1 factorial. Then inside here, I'm going to write n minus 1 minus x minus 1 factorial, x minus 1 factorial, p raised to power that. And this is going to be n minus 1 minus s minus 1. Take a look at that. Okay, take a look at that. Okay, now when you take a look at this now, I can let k be n minus 1 and n be x minus 1. Then if I want to rewrite that, I'm actually going to have, instead of that, I'm going to have k factorial, okay, k minus m factorial, then m factorial, p raised to power m, then q raised to power m minus k. Let me see. N minus 1. Okay, that would be k minus n. Okay, now if you take a look at that now, okay, this is the same thing as k, that's right, this, okay. If you take a look at that, this is another binomial, right? That's another binomial, right? If you come back here, that's another binomial, right? Okay, and the sum of a probability has to be equal to 1. So the whole of this is actually 1, because the sum of a probability distribution has to be 1. So here now, I'm actually having NP times 1. So expected value of S is NP. Is there any question on how this is derived? Any question? Like I said, go ahead.
Can you explain the n minus 1 and x minus 1?
Explain what?
Can you explain the n minus 1 and the x minus 1?
Here, right? Here.
Here. Right.
Okay, how this one become this? Yeah, it's mathematically speaking, if I have k factorial, it's the same thing as k into k minus 1 factorial. So for instance, if I have 5 factorial, 5 factorial is 5 times 4 times 3. So I decided to stop here because, if you take a look at this, right? I stop here because I want this s to cancel this s. I can decide to go all the way. Okay, that's mathematics. Okay, so that is how. Now, if you want to, for the variance, some of you may be wondering, why is it that some of these equal to 1? Okay, if I have this to be this, right? If you want to go by binomial expansion, okay, a plus b raised to power n. This is going to be n combination s. Do you understand? If you go by, this is from binomial expansion, a plus b raised to power n is this. And if you take a look at this, go ahead. N combination s. S start from 0 to n.
The first expression.
A plus b raised to power n. Yeah, this one?
Up above. Is that an x? Like, because I just can't see.
Yeah?
No. In the first one, the p of x equal x.
You mean up here, right?
Yeah, is that an x? I just can't.
This is p n combination x.
Right.
P raised to power x. Q raised to the power n minus x. Did you see now? Okay, now when you compare this with this, let's compare. A is the same thing as P, right? B is the same thing as Q, right? So here now, if I want to apply that, the probability of this now, so if I have this, P raised to the power S, where S start from 0 to n, this is P plus Q, right? If you want to go by this. What is P plus Q? That's 1. Because P is the probability of success, Q is the probability of failure. Of course, we know P plus Q equal to 1. So here, 1 raised to the power n is also 1. Okay? Just wanted to take note of that. Okay.